Okay, welcome back. This is the second video of the series. Got the rest of the parts, at least workable parts, for this mini badge. So looking forward to this. I also got, let's go out of it, the schematic here. So this is a schematic going through, kind of verify the traces. You see all the fast switch diodes, transistors, the 4017 chip, which has their pins going to the wrong place. That's one area to check in your schematic. Also has the 555 circuit and other aspects. Really clean. I like the separations into it. Makes it a little bit easier to follow and read through different sections. Did a good job on the schematic layout. And this is where we left off last time. Let's zoom back in. We got there with the wires. This is a clean board. And then the rest of our parts are here on this side. Sorry about that. Zoom to a decent area. Put that board off to the side for now. These are kind of lined up on how they go. So this would be R1, which is 10, R2, R3. Not quite right. These are, I think, about 30 ohms. I'll have to double check that. And that's our 20K ohm for R4, and then R5 and R6 are 10K. So they'll be right here. Get our solder out. And then I believe this is a capacitor, and that's definitely a capacitor. We're going to do this up with the normal circuit. Like always, get your iron ready and tin the tip. All right, still heating up. Okay. Let's prep. These. Some of these are going to be a little bit harder than others to do, just due to the nature. And I did misspeak in my first video. This is actually ground. The clock's over here. That ties up to this front LED. Some of these are going to be a little bit hard to install since I've already put on the headers. But we'll get into it. Let's see. So the capacitors, C2 is our 10. Which I believe is that one. When in doubt, always get out your voltmeter. Hopefully it has a capacitor checker. But let's actually do, that is 1, 2, 3, that's 4, 5, oh yeah, and 6 is down here. So 4, R4 is our 20K. I should be able to double check all these values too before I go. That's yeah, 19.99 kilo ohms. So perfect. This is the tricky one to install. Actually kind of excited to see this one up and working. Yeah, big shout out to Cyberm3n for letting me do this. Okay. Since I'm working on those ones, I'm going to do R5 and R6, which both should be 10K. This should be this 103 resistor. Here. Doing this check. Yep. 10K on the button. Get that right on. And this one right on. A little crooked there. Not too much. Okay. Now let's do that C2. Should be this one. Double check. Here's my meter. Move it to the so yeah, this is about 10 microfarads. It's kind of hard to show the meter on the video at the same time. But you can see there some of the capacitance aspect. Get the nice reading. Okay. So that's our C2. Let's install that. Maybe. Okay. Probably need just a little bit more solder on the other side. Let's do this. That. Okay. Now I believe this is also a capacitor. So let's open it up. Let's verify. Yeah, it is a capacitor. And let's double check its value. Same philosophy. Get your multimeter out. And check it. So this is right about 10 nano, so 0.1, 0.01 microfarads. So reads out right. And this one's going to be a little bit more tricky because this is where I have my bodge wire. So this one was going to ground. Ideally, this would be installed first before you did your bodge wire. So I'm probably going to have to add a little bit of solder to the bodge wire part. Okay. And I want to make sure that it's still connected fine without any issues. Okay. Now let's do this IC. This is a 555 timer. It's a fun little chip. Do the circuit a little bit different than normal for this. So, get right on. Okay, and then gently do these pads. Try not to melt any of your bodge wires as you do this. So you'll be doing the bodge wires after you install everything. Not your normal process. Okay. A finer tipped iron will help quite a bit. Okay, we got that done. Now, this one should be R1. It should be 10 ohms because it's 100. Like always, get out your multimeter. Make sure it's in the right mode. Yep, 10 ohms. Yeah, not showing the resistor aspect. Okay. Connected. Okay. Yeah, you have to be careful with these small ones. You can heat up both sides of the pad pretty easily with these little resistors. Because these next two, it's supposed to be a 20 and a 220. I think I only have 30 ohm. Not sure what these ones are. It should work fine. I'm actually kind of worried about how big the one is. So let's take a look at these. This, I believe, says 300 on it. Due to that, I'll show my multimeter for this one. So yeah, these are 30 ohms. So it should work. Just fine with it. I do have this other one. I think it's a 10. So the schematic wanted a 20 and a 220. I'm going to put 230. Two 30 ohm resistors on instead. The transistor circuit might have more of an effect on it, but I think it'll be fine. Okay. Okay, solder on these ones, and then we'll do the LEDs. Okay, these orange ones are these 4-post ones, and then these yellow ones, single. Let's do the single ones first. Out the package. Okay, it looks like you go that way into the box. A bit hard to see from the top. The bottoms are marked well. So orient them all in. So I'll point into the square. Hey, these ones, one should be probably installed upside down, and the other one on its side. So I'll add a little bit more there. One for on that side. I want to do it like that. Oh. It's a little more tricky to install it these ways. Okay, and then this one, side of both windows. We could do it normal and have it reflect. I'm gonna just do it upside down. So down soldering requires a lot more solder on one side. Not the ideal way of doing this. Okay, so this should be on. So it gets everything there. I think all pretty good. It's bridged. By accident. Okay, and then let's look at these last ones. I believe these ones are RGB, which they are. They're the 4 pads here. Nice thing is that it looks like there is a green line for where they go. Let's zoom a little on these. Let's see if we can do a closer view for these LED installs. Oh, and of course I installed it backwards. So let me redo that. The right way. Okay, I think that'll be good. Good. This is a little different. This one's a little harder. I have the header already installed. So I'll come back to that one. Okay, let's try this yet again. Okay. finish soldering this together. I can get connections to all those pads. Okay, I think I got. I got that one all connected. All connected. This one all connected. The really hard ones. Okay. Okay, hopefully they're all connected. Really hard here. Okay, at least got one. Other one. And this last one. Maybe. Oh, I think I melted my bodge wire a little. Okay. That's good. Okay. Zoom out a bit. That's all together. Let's verify that we fixed the board. First time plugging it in. Make sure it's in the right orientation. Goes in. Okay. So all those lights lit up. That's good. None of the RGBs are lighting up. At least I can tell from the one aspect. So I'll have to look at that, trace that, but it's so far a pretty good working badge. Not getting warm, so that's good. And just a sec, I'm going to go look at those other LEDs to make sure it's all working how it should be. Okay, let's take a look at this. The nice thing is that the board's not getting warm and it's working. But I'm not sure it's because of the low battery, low resistor on that one or not. So let's look at the schematic here. You have the RGBs all in. Let's do some tracing and make sure these are all installed correctly. So that should be the negative. Of course, this all goes through that one resistor here. No, one resistor, R3. Should have, not sure what side of R3. Should all be. Did I install them on upside down? Let's take a look at this. Nice to have another board. Okay, so pin 1 should go to ground. So I'm not getting a response. Okay. So pin 1's ground. At least it should be going green. Interesting. Those ones are tied together. Those ones are tied together. That should, oh. So after that, okay. So it looks like there's a connection missing. These are tied. That's tied. But that is not tied. Okay, so it looks like those LEDs aren't on as well. So we'll do a yellow. Yeah, yellow for show. But these might be installed backwards into it. Pin 1's going to ground from this chip. So we can verify these other ones are coming from pin 2. Oh, goes through quite a bit. These are all grounded. Very complex circuit. Oh. That's not good. Looks like it's short to ground. Or my leads were touching. Which probably is the more truthful case. So this should go up. Let's see, Q1 through Q6, Q6, BC should go to green 2. Green 2 is D6 and D7. So that should be pin 3. 1, 2, 3. Okay. So that should be right. Okay, welcome back. Last little thing, ran through some slight issues when we were plugging it in to go through. Found out the issue here. There's actually a few issues. Let's get to a bigger video. Okay, so with the schematic, the one that I've even done a mistake with is that you have your transistors, EBC, and oftentimes this won't match the footprint exactly. So if you grab the wrong footprint into in KiCad on the PCB side or tie it to, you'll end up getting it so it's easier to see on the put together one. It's laid out just how it is on the picture, and that's not always the case. Usually that B is actually that first one, and that's C and that's E. So it goes BCE normally. So right now this one has the C connected to the ground part, when it should be going to the net. E is set up to go to the transistors, and B is going out to the net, so it's not going to work here to run this. Everything else ends up working, and then the RGB LEDs that end up getting are common anode instead of common cathode, which doesn't work on this circuit. So only the green LED will go because power goes in one and the grounds change instead of the ground being the same and the power changes. So that's one issue there. So I can either bodge the three and it'll be this a full RGB light up, or just keep the green, or else I can cycle it and have just do two of them and get unique colors into it. That's the parts I've learned as I went through. The clock works fine. To go into that for testing, I'll show you what I did. Zoom in just a little bit here. So for testing purposes, I got a bodge wire. I just connected it to this pin here. My tip needs to be, oh, my iron needs to get to temp. Okay. So to recreate this, testing, I went in to make sure the clock, it was all working with that 555, nothing issue there. Zoom out so you can see everything here. So now I have that tied to that one pin, which is a green one on the badge. And then I can come down with this bodge, and luckily I can hit the parts. So I'm hitting this transistor here. As you can tell, it's blinking on its own clock cycle. So that was working. I also tested on a few of these to make sure they worked. So they're all working as they should. So to get that basic one working, you'll have to just take a bodge wire and go for, zoom in, go from the upper right pin, because that's where the common anode is, the positive side, I'm saying that right, and tie it to just one of these transistors here. So it will light up both LEDs at the same time, so it doesn't matter which one you choose, and do the same thing on this other side. Also learned that the ground pin here was not connected going through my analysis, so I connected ground to one of those. It's not tied to a resistor like this other side, so this will be a little bit brighter than the other one. And then I figured out my LEDs were done that way. I got out my other multimeter that can do a little bit higher voltage. This is actually a pretty nice multimeter for the price. Really pretty impressed with this little Chinese multimeter. Let's zoom fully out here so you can see. So I took it in, moved it to the diode setting, put it on this one pin here. Let's do the green. So start with green, and I cycled to the other ones. Noticed they didn't light up, so I took the ground one and started moving it. So that's red, and that's blue. So red, green, blue, all going in. That's when I learned that this one, the ground switch and not the power, doesn't work with this circuit per se. And then I also learned that this side is ground, and then when I went over here, it wasn't quite working on this side of the resistor. Now it is, because I have everything tied together, but initially it wasn't working. If I pull out the other board here and go to continuity, so I went there to ground, there was no beeps, or to any ground at that point, nothing was beeping. It does connect to the other RGB fine, so I knew those were done, but there was no connections to ground. Those were the two other big issues on this board. So you can merge the two bottoms to ground, and then you'll get a blue-green combo, so purplish, not purple, that'd be orange, yellow, those realm, can't quite remember. And then the transistors are messed up. A little bit harder to fix the transistor setup, as you have to swap. Let's zoom in a little bit closer here. You would have to swap this pin and that pin together, and some of these have vias, and that's not going to be an easy part, so you'll have to actually put the transistor kind of up and do special bodge wires to fix that aspect. Very common mistake with transistors to go into, but overall a great board. I'll sit and solder up this with the bodge wire and play around with. I have two bodge wires here, and I'll connect them together. I might actually bridge these bottom two here to see. Do be careful with the LEDs. I don't know if I'll be able to bridge the bottoms. I might. And then just randomly choose one of the right-hand sides of the transistors. So sadly, without switching out my LEDs or really changing a lot of the circuit, so it provides grounds instead of powers. Let's go in, do like my tweezers. For soldering this together. Figured out all the issues on this board. Overall not bad. Probably would just redo because of that transistor layout issue. That's a really hard one to overcome. And then if I take this one and solder it on to add a little bit more solder to the pad so we can solder this on. So they can't see the cool switching of the RGB colors that this was designed for in the current state. So with that modification, we should be able to now plug this in, go out a little bit. And then you see the cool green lights going off. As you can tell, I didn't quite fully bridge those bottoms there. Let's see what happens if I do bridge. Those bottoms, I do have a little bit of leads here. Let's just do it on this one. It's a little bit hard when the lead's really big. To what you need. Okay, I think that bridged. Let's see if it works how I think it will. We should end up with a little bit different color than the green. I guess I didn't quite fully get that bridged. It gives you an idea. There of how this badge works. Really cool, really complex design. Has some circuitry that I'm not that familiar with. With those fast switching diodes, really cool. Just for fun. Yeah, I'm fully shorting out that. So green takes precedence, so you can't really short the grounds on this either. The LEDs just don't work that way. There you go. This at least gets the green going. Pretty cool to go through. Really cool mini badge. And excited to see what Cyberm3n does next year. And as you can tell, it works really good. Thanks for watching.